All right, guys, today we're going to take a look at the 5.1 kind of a preview section before we actually start section 5.1, just because I think it's important we review a couple of skills. One, the better we know our identities, which we used in chapter 4, the easier this will be. And there is a lot of factoring in this section, but not just plain easy stuff like x squared plus 4x plus 3. They are going to have trig functions. It might be sine squared plus 3 sine of x plus 4, etc. So they're going to have trig functions in there. So we're just going to work on our identities here really quickly. Hopefully we know some of these. They're on your sheet, obviously, but like I said, the better you know them, the easier this will be. And then we'll get into some factoring. Of course, the reciprocal of cosine, we should know it. 1 over secant. Tangent, 1 over cotan. Sine, 1 over cosecant. Cosecant's 1 over sine. Cotan, 1 over tan. And secant, of course, 1 over cosine. So reciprocals, of course, flipping the fractions. Now, our quotient identities, we've used those last chapter. They're going to come up. We use probably tan a little bit more. Tan, of course, sine over cosine. But we will be using the one for cotangent, which, of course, is the reciprocal of tan. So cosine on the top, sine on the bottom. We will see our even odd functions. Now, the cheat on this, I just memorized which two functions are even, which are cosine and secant. So that means when you replace x with a negative x, you get the original function out. Same for secant. And then I just recognize the rest of the functions are odd, so we get the opposite. And that's how we represent the opposite, a negative, opposite, opposite, and opposite. Again, you've got these all on your identity sheet. X, that's an X. But it's important, the better we know these, the easier it will be. Okay, cofunctions, I have them in the degree style. If you look at the bottom of your identity sheet, there's 2 columns, degree. Then, of course, they have the ingredients with the pi. Same thing, just know them. The function of tan is cotan. The cofunction of is cosine. Cofunction of cosecant, take off, secant. Cofunction of cotan, take the co off. Cofunction of secant is cosecant. And then the cofunction of cosine, take the co off, sine. There we go. So again, those are all on the sheet, but we're going to see those more and more throughout the chapter. Okay, verify the following. This is the bulk of what we're going to be working on. When it says verify, you are proving, yes, prove, or showing me why the one side equals the other. It may seem counterintuitive, but it's easier to work with the more complicated side and try to simplify it down to the easier side. If I start on the right, if I start with sine, I mean, that's difficult to try to figure out what to do to that to transform it into the left. So I'm going to work on the left side, the more complicated side, and I'm going to try to show that that does simplify down to just plain old sine. Well, first up, identity. Sine of pi over 2, that's that cofunction identity. The cofunction of sine is cosine. There's technically a times between it. I just put the dot. We all know it. So it might not seem like we're getting there, but we kind of are. Because, of course, there's some identities now for tangent. Now, there's choices on your sheet. Tangent, of course, 1 over cotan. I don't think that's going to help me. Tangent, of course, is sine over cosine. Ah, that's going to help me because now the cosines, of course, cancel each other out, and we've got it, sine of x. So this is what we were doing the majority of this chapter. You were showing me the one side of the equation really does equal the other side with your identities. This is why I said the better you know your identities, the easier this is. You don't want to have to keep scanning through your sheet over and over. Okay, I'm going to work on the left side, more complicated. Clearly, this is an odd-even identity. Secant is even, so it equals the original function. And I'm going to leave my cosine. Now, more identities, choices here. We can make secant 1 over cosine. And I'm going to show you the other way. Clearly, cross those off, we're going to equal 1. And just to show you, and again, I don't care how you do it, I'm going to pick it up here. You could have left your secant and made cosine 1 over secant. and you will get your 1 also. Doesn't matter how, just as long as you have the work to justify that you get to 1. And I won't always show you every single option, but as we start here, I'm going to show you clearly there are different ways to do it. All right, clearly I'm working on the left side. Identity, co-function identity, the co-function of co-secant. Take the secant off. And then I still have my secant. Well, that was easy enough. Secant times secant, secant squared. I like that. That's short and sweet. Kind of like me. Okay, left side. We're going to start with that one, of course, and more complicated. Another odd-even identity. Cotangent is odd, so we get the opposite. I'm going to start with that. Now, we're trying to, of course, turn this into cosecant. That's what we're going to work on. Here's a little pro tip, and you'll hear me say this throughout the chapter, because there's choices on that cotan. We could do 1 over tan or cos over sine. Whenever you're like, oh gosh, I just don't know which one to use, okay? My pro tip to you is try to get everything in terms of sine and cosine. Go with those functions. So cotan, I'm going to do the cosine over sine. Secant, 1 over cosine. Now my cosines cancel. Oh, I've got it, because I'm down to negative 1 over sine. And of course, negative 1 over sine is cosecant. So if there's multiple identities you can pick from and you're not sure which one to use, my pro tip, of course, write everything in sine and cosine. Okay, factoring. Factoring comes up a lot, of course, with these trig functions. Now, just to show you what we're really doing, it's just like if I said, hey, factor this green trinomial. The difference is we have trig functions in there. You have cosine of theta versus x. Now, the factoring process is the same. I'm going to start by multiplying the outside two numbers. 2 times negative 33, negative 66. I'm going to figure out two numbers that multiply to negative 66 and add up to the middle. So negative 22 times 3. That multiplies to negative 66. It adds up to negative 19. Now, key step. Our lead coefficient, of course, is a 2. So I have to scale these or divide these by 2. 22 over 2 comes out nice. 3 over 2, it just is what it is. I'm going to leave it. Now, if I was just doing the right one with the x in it, super easy, x minus 11. And don't forget your denominator on the fraction goes in front of the variable. But we're going to write the same thing, but instead of x's, we're going to put cosine of theta minus 11. 2 cosine theta plus 3. So the factoring process is the same. We are just doing it with trig functions. Okay, let's take a look at the next one. Difference of perfect squares. 9 is a perfect square. Sine squared is a perfect square. 1 is a perfect square. So it's clearly to get 9, 3 and 3, 1 times 1. Okay, so to get 9 sine squared, we're going to need a 3 sine of theta and a 3 sine of theta. Of course, to get 1 times 1. Difference of perfect squares, you have opposites. We have one positive factor, one negative factor. That makes the middle terms cancel out, and of course 1 times negative 1 results in that negative 1 at the end. Got it. So no different than factoring with x's in it. Okay, trinomial again, lead coefficient 5, so I have to go through that process where I start by multiplying the outside numbers. 5 times 1. I need two numbers that multiply to 5 and add to negative 6. Now, because our lead coefficient is a 5, we're going to scale these both by 5, or divide them by 5. Negative 5 over 5, and I'm going to leave the fraction. Okay, I'm ready. So, tangent of x is our function, so I'm going to have tan of x minus 1. And then my other factor, the denominator, goes in front of our variable, which is tan of x, and then minus 1. Got it. So our process is the same, we just have our trig functions in here. All right, let's take a look at D. This one's actually a little bit easier because trinomial lead coefficient 1, so I just have to ask myself what multiplies, kind of that shortcut factor, what multiplies to the last number and adds to the middle. All right, so let's figure out the numbers. It's going to be negative 4 and 2. This time I don't have to worry about scaling them by the lead coefficient, because if I divide them by 1, it doesn't affect them. That's why this is kind of that shortcut factoring method. But of course, for a variable, I'm going to use secant of theta minus 4, and then my other factor secant of theta plus 2. So just some prerequisite skills that the better we are with factoring, and then a few verifying. Ignore this pop identity quiz. This is from a previous lesson. I'm not going to be that mean to you. Okay, have a great day.